Okay, let's get it.
Notice that I'm starting to.
I think it's because I'm starting math.
There we go. Hopefully that'll work.
Thank you.
Okay. Okay, so real quick, have a look up here. So the generalized second fundamental theorem. So this is really valuable, I think. So all this is, it's just saying this, right? If I've got the derivative with respect to x of some definite integral written in terms of the dummy variable t from a constant up to some function of x, then this is all you have to do. All you have to do is you're just going to evaluate the integrand at whatever that function is. So you're going to get f of g of x times, it's kind of like a chain rule thing, times the derivative of the function that's forming the upper limit. That's it. Okay? So times g prime of x. So for example, this looks really complicated, but it's not very hard at all. In fact, these are sort of freebies. So if they're telling us that we've got this area function, capital F of x equals the integral from pi to secant of x squared of this big ugly thing, sine of the square root of cosine t plus t cubed dt, then find the derivative of that prime of x. Well, then all we do, literally all we do, is we're just going to plug secant x squared in for t everywhere times the derivative of secant x squared. That's it. So our answer is, see, here's the first part, right? So the first part is just what we get when we substitute the upper limit, which is a function of x, and we substitute that for t. That's all we got. See, look, that's it.
Oh.
Just plugging them in, times the derivative of secant of x squared. Well, what's the derivative of secant of x squared? The derivative of secant of hand is just secant hand tangent hand, right? So secant x squared, tangent x squared, times the derivative of hand, the derivative of x squared is just 2x. That's it. That's the big answer. So I would just put all this stuff maybe out front, right? Out in front of the square root, or the sine of the square root. That's it. There aren't any super duper hard ones on there, but there's a couple, like on that last assignment, nothing probably quite this hard, but there could be. It's not like these are, here, let's just try one real quick. So what if I gave you, so what if I gave you one like this? What if we wanted to take the derivative, what if we wanted to take the derivative with respect to x of the integral of, let's just say, sine x squared, oops, make it t, how about? It could be x, but we'll make it t. From negative 11 to, how about, up to x cubed.
So we plug in it.
Yeah, so we're going to get two parts, right? First thing we do is we're just plugging this in for the dummy variable t, right? So the first part is just going to be sine of x cubed squared, which is what?
5.
X to the 6, right? So that part's just sine of x to the 6 times the derivative of x cubed is what? So then our answer just looks like 3x squared sine x to the 6. Done. That's it. And so then there's nothing like this on the test or the homework, but just so you have this for college, then you could also, you could do like an ultra generalized version of this where you've got functions as the upper limit and lower limit, and this is all it is. This is what it works out to be. So you're just going to end up with the function evaluated at the upper limit times g prime of x minus the function evaluated at the lower limit times its derivatives, call it h prime of x. Now All right.
Thanks, sir.
You betcha. Oops. Oh, I did record. Good.